Have you ever wondered how researchers select their study participants? This process, known as sampling, is a critical aspect of research. In essence, sampling is the selection of a subset from a larger group, which we call the population. The aim is to select a sample that accurately represents the characteristics of the population. Imagine trying to taste a soup. You don't need to consume the entire pot to understand the flavor. You take a spoonful, a sample, that ideally captures the essence of the whole. But in research, getting a perfectly representative sample can be quite a challenge. There are practical obstacles to consider, like time, resources, and accessibility. So instead of aiming for perfection, researchers strive for the most representative sample achievable within their constraints. Sampling is a crucial step in research, but how do researchers decide which method to use? Well, let's dive deeper to find out. First, let's dive into the world of probability sampling. In the realm of research, probability sampling is like the gold standard of sampling methods. It's the method you turn to when you want your results to be generalizable to a larger group, the population. Now you might be wondering, what makes probability sampling so special? The answer lies in its core principle, randomness. In probability sampling, each member of the population has an equal chance of being selected for the sample. This is like drawing names from a hat. You don't know whose name you'll pull out, and that's the beauty of it. It's fair, it's unbiased, and it's statistically sound. This random selection process ensures that your sample is representative of the population, increasing the likelihood that your findings can be generalized. It's a method favored in quantitative research, where the goal is to draw conclusions that will hold true for the wider population. But let's not forget that probability sampling comes in many flavors. There's simple random sampling where each member of the population has an equal chance of being selected. Then there's stratified random sampling where the population is divided into subgroups or strata based on a common trait, and participants are randomly selected from each stratum. And let's not leave out cluster sampling, where the population is divided into naturally occurring, mutually exclusive groups or clusters, and a set of these clusters is randomly selected. Each of these methods has its own set of advantages and limitations. The key is to choose the one that best fits your research aims and questions. It's about finding the balance between the ideal and the practical. But probability sampling isn't the only game in town. There's another approach, and it's called non-probability sampling. So, what is non-probability sampling? It's a great question and one that's central to our understanding of research methods. Non-probability sampling is a distinct approach to selecting a subset of participants from a larger population. Unlike probability sampling, which relies on statistical randomness, non-probability sampling is based on the researcher's discretion and judgment. To put it simply, researchers using non-probability sampling methods don't aim to give every individual in the population an equal chance of being selected. Instead, they strategically choose participants based on specific characteristics or qualities that align with the study's purpose. This deliberate selection process is what sets non-probability sampling apart from its probability counterpart. You might be wondering, why would a researcher choose this method? It's an excellent question. Non-probability sampling is particularly favored in qualitative research, where the richness and depth of data are prioritized over generalizability. This approach is all about gaining a deeper understanding of a particular group or phenomenon, rather than seeking to make broad generalizations about the entire population. Non-probability sampling can be incredibly useful when working with a specific subgroup within the population, or when the population itself is hard to define or access. It's also valuable when the goal is to explore new areas of study, where depth and detail are more important than statistical representation. However, it's worth noting that non-probability sampling comes with its own set of challenges. The lack of randomness can lead to selection bias, which can affect the validity and reliability of the research findings. The results of a study using non-probability sampling may not be representative of the entire population, limiting their generalizability. But remember, no sampling method is inherently superior or inferior. It all depends on the research question, the nature of the study, and the resources available. Non-probability sampling has its unique strengths and can provide valuable insights that might not be possible with a purely random approach. Now that we understand these two main approaches, let's explore some specific methods under each. There are several methods under probability sampling. The first one we'll explore is simple random sampling. Imagine a hat full of names. You close your eyes and pick one. That's what simple random sampling is like. Each participant in the population has an equal chance of being chosen. This method is straightforward and unbiased, but it assumes you have access to the entire population, which isn't always the case. Next up, we have stratified random sampling. Think of a population as a fruit basket. In this basket, you have different types of fruit, say apples, oranges, and bananas. Stratified random sampling would first divide these fruits into separate groups, or strata, and then pick a random sample from each group. This method ensures that each subgroup is adequately represented in your sample, making it ideal when you have a population with distinct categories or traits. However, it requires detailed knowledge about the population, which may not always be available. Finally, let's discuss cluster sampling. Imagine a city map. This city is divided into different districts. In cluster sampling, you'd randomly select a few districts, then randomly select households within these districts to participate in your study. This method is useful when the population is spread over a large geographical area. However, it may lead to less accurate results compared to simple random or stratified random sampling because of the potential for similarities within clusters. Each of these methods has its advantages and limitations. Simple random sampling is unbiased, but may not always be practical. Stratified random sampling ensures representation of all subgroups, but it requires extensive knowledge about the population. Cluster sampling is convenient for large geographical areas, but may compromise on accuracy. So, the choice of method would depend on your research objectives, the nature of your population, and the resources at your disposal. And remember, no method is perfect, but some may be more suitable for your study than others. Each of these methods has its place, but what about non-probability sampling? What methods exist there? Like probability sampling, non-probability sampling has its own set of methods. Let's delve into three primary methods: purposive sampling, convenience sampling, and snowball sampling. First up, we have purposive sampling. This method is also known as judgmental or subjective sampling. Here, researchers select participants based on the study's purpose. It's like choosing the right ingredients for a unique recipe. Researchers use their knowledge and judgment to handpick participants who will provide the most relevant data. However, while this method can yield rich, targeted data, it's worth noting that the risk of bias is high. The sample may not represent the wider population accurately due to this subjective selection process. Next, we have convenience sampling. As the name suggests, this method involves choosing participants based on their availability and accessibility to the researcher. It's somewhat akin to picking apples from the lower branches of a tree because they're easier to reach. This method is often used in exploratory or pilot studies due to its ease and speed. But while it's indeed convenient, it may not yield a representative sample as the selection isn't random. Finally, we arrive at snowball sampling. This method is particularly useful when dealing with hard-to-access populations. Imagine rolling a snowball down a hill. It starts small and gathers more snow as it rolls, growing larger over time. In the same way, initial participants in a study refer others, and the sample grows organically. This method can help reach populations that might otherwise be difficult to study. However, as with the other methods, there's a risk that the sample may not be representative, as the selection process is based on participant referrals rather than randomness. In summary, these non-probability methods, while potentially introducing bias and possibly limiting representativeness, can provide rich, in-depth insights. They can be particularly useful in exploratory or qualitative research, where understanding specific phenomena in depth is more important than broad generalizability. It's clear that both probability and non-probability sampling have their own merits and drawbacks. So, how do researchers decide which sampling method to use? It all boils down to the nature of their study. The research aims, objectives, and questions are the guiding lights. If a study is seeking broad, generalizable results, probability sampling methods like simple random, stratified random, or cluster sampling might be the way to go. But if the focus is on in-depth insights, non-probability sampling methods like purposive, convenience, or snowball sampling could be more fitting. However, the method isn't the only factor to consider. Practical constraints such as resources and time also play a vital role. It's about finding the sweet spot where a representative sample and feasible execution meet. And let's not forget, each method has its limitations. Transparency about these limitations is crucial. Remember, a balanced approach, understanding the trade-offs, and clearly articulating the limitations of your chosen method are essential for effective research.